Okay, so here I'm opening the file and selecting all of the objects that came in from Gravity Sketch, and actually here I'm deleting some of those cross members. Now I select all of the files except the reference object, and then I combine them. So they're still intersecting each other. They're not a single part, but they're all on one object or one layer. So now now I'm scaling the object because it came in very small. So I'm taking a known dimension of the board, which I've measured at 22 millimeters, and scaling it, and then I use the align to send it to center it at the origin on the print bed, and just turning it around with the transform tools so that it's sitting flush on the bed. So here, in the last video I talked about tolerances of parts and how it's best to do it in SolidWorks, but if you don't do that, you can scale your part in a known dimension, or in one dimension, to in this case to increase the size of the gap that will be cut in the part. So here I'm getting into the remeshing. Whenever you're doing intersecting or differences, you want to have a lot of triangles. So as you can see, that reference part only has a few triangles to begin with. So now I'm selecting all the areas that intersect with the part, and I'm increasing the face count. And I'll do that several times so that there's a lot of triangles. This helps it successfully do the difference, and it also does it much quicker. So now I'm doing the same thing to this one, and I tried quite a few times to connect that one leg to the base of the part, and as you can see, it's kind of throwing all the faces out, and I had a lot of trouble with the parts intersecting each other and then not meshing as a solid. And I tried it a few times, and then as soon as I tried to make it a solid part, it would crash. And unfortunately this happened several times, and it was kind of frustrating. But with a lot of this stuff, it's kind of a case-by-case basis, and it just kind of tests your knowledge of how to use Mesh Mixer. I really don't like working in meshes. I'm used to SolidWorks and parametric design, and that said, Mesh Mixer is a really powerful tool, especially for this kind of stuff where there's no dimensions. And here I'm trying same thing. I'm trying to increase the face count, and then put those parts back together. Unfortunately, with this whole process, there's really no the splines aren't preserved. So once they're exported from Gravity Sketch, there's no way to go back and edit the part, which for me is a little bit of a problem because I don't have a VR system, so I have to go back to campus and schedule time and do all that. But even if that's not the case and you have yours, it would still be nice to just be able to move one of those spline points over just on the computer without the headset and all that. So even minor changes, you got to go back into VR and open up the drawing changes and then re-export and then re-import to Mesh Mixer, and basically any change you're starting over for all this meshing, which is actually, it takes just as longer than actually drawing the part. I find that there's kind of a fixed time cost on the meshing, except in this case, which it took a lot longer than it normally does. But even if it takes you 10 minutes to draw a part in VR, it still takes like 45 minutes to get the meshing done. Yeah, here Mesh Mixer crashed again. Okay, so I think this is the when it starts working. The important thing here is turning off these close open boundaries and auto repair result. That was causing a bunch of problems. So now that I know it's working, instead of using the sculpt tool to bring those together, I'm just dropping in an extra part to connect those, and it's treated just like another one of the pipes or the objects from Gravity Sketch. So I kind of just drop it in, and then I recombine that layer, make a backup. Now I'm making it solid again, and then here I start playing around with the solid accuracy and the mesh density, and I'm trying to get rid of these those flat faces that are showing up on the cylinders, but that I found it has more to do with the ratio between those two sliders than it does with any set of positions. So doing a final update, and then nope. Yeah, okay. So now I'm going to go back through and select the areas where this part is intersecting with the board. Oh, now that it worked, I updated it to, or made this the main file. So those are the two faces that touch the board. So remeshing, increasing the polygon count. Doing it again. So here I'm going in and with using the sculpt tool, just kind of smoothing out those faces. That also kind of automatically causes it to remesh, or at least even if it doesn't change the mesh density, it just moves everything around. So here I finally made the reference part a solid as well, and making sure to keep sharp edges preserved, otherwise it kind of rounds the corners, which would be a problem. Make another backup. So now I'm going to subtract the solids from each other, and that worked right out of the right on the first go. Okay, well, after trying a whole bunch of different stuff, finally got the subtraction to work. and it is ready for printing. So as the last step, I'm going to turn the printer bed back on and then do a cut plane. Okay, printer bed off so we can see the bottom. And what we're looking for is a constant flat surface. So looks like we got that. Now right here, that might be a bit of a problem where it clips into the board, but I'm just going to leave it and see how it turns out. Export as STL. Okay, so here's the file in the slicer for the printer. I'm going to do everything 100% infill, no supports. Looks good, hour and 20 minutes. Bit of weirdness going on there. That might cause a little lifting, but I think it's just in the first layer. Yeah, that's okay. So okay, so just came off the printer and looks pretty good. It didn't take any cleaning or post-processing. It just kind of slipped right in, and just as expected, it flexes on the base and then snaps. And then the cable fits down the back side, and I'll just secure that with a zip tie. And then this goes like that. And there's our VR to 3D printed part.